microprocessor. Before starting the given that 85 microprocessor, let's look at the traditional block diagram of the basic computer. A computer consists of input devices, output devices, and memory blocks where we store the data. When the computer takes the input devices, it will process the input given by the input devices for the CPU. Now, CPU has two components. One is the arithmetical logical unit, second is the control unit. All the process has been done through the arithmetical logical unit. Process means work. Work has been achieved through the arithmetical logical unit, and which type of work has to be achieved is controlled by the control unit. Now, when we are working on the CPU, for understanding of the CPU main component is the microprocessor, which works as a CPU, central processing unit in a computer. Now, CPU can communicate with the memory or input-output devices. Even it can communicate with the other peripheral devices, like it can convert analog to the digital, some type of timer can be achieved, and serial communication also can be done through the microprocessor. Now, the word microprocessor means now micro is because this device consists of lots of transistors which are of a small size, like a micrometer size. In a micrometer size, therefore micro. From micrometer comes micro. The processor which do the working, which do the processing. Therefore, it's known as a processor. A device which can process the input to create output. Before going further, let us understand 8085 microprocessor historical point of view. It is the 8-bit microprocessor. Firstly, it is produced by the Intel company, introduced in March 1976. Then it is discontinued in 2000. Common manufacturer of the 8085 are Intel, and others are also there. The successor of 8085 is 8086. Features which are the basic needs of the today. It is the 8-bit data bus. It also has 16-bit address bus which can address up to 64 kilobytes memory. A 16-bit programmer to access such a memory, and a 16-bit stuck pointer to access the stuck memory. Apart from this, it has a 6 8-bit register pair like BC, DE, HL pair, which work for the 8085 processing. It requires 5-volt supply with 3.2 MHz single phase clock. The pin diagram of microprocessor is somewhat like this of 8085. It's a 40-pin IC. Now, to understand these total 40 pins, I have divided this 40-pin package of microprocessor into the small blocks. Like for serial communication, we had 2 pins, SID and SOD. S for serial, I for input, D for data. Similarly, SOD, serial, O for output data. Then, apart from the serial communication, we have interrupt signals. Now, interrupt signals. Before starting understanding the interrupt signals, we have to understand the word interrupt. Interrupt means some sort of interpretation, some sort of what you can say. When someone is walking and you interrupted in his work, the word interrupt comes. Here you can interrupt 8085. So the 5 signals: drag, RST 7.5, RST 6.5, RST 5.5, and INTR. There are 5 interrupt signals 8085 through which the 8085 can interrupt it. Apart from this, it has externally initiated signals like ready, hold, and reset it. Now, when it communicated with the peripherals, there is a possibility that peripherals need the acknowledgement that 8085 has got the signal. Like when 8085 provided INTR, that is the interrupt signals, the 8085 provides its acknowledgement through the INTA, interrupt acknowledgement signal. Similarly, when the hold signal is provided to the 8085, it has been acknowledged through the hold acknowledgement HLDA. So these two external signals is acknowledgement signals. Then we have a control and status signals like ALE, S0, S1, IO/M bar, RD, and RW. ALE, address latch enable. It enables the address bus in the next machine cycle. I will explain in the coming slides. S0, S1, and IO/M bar also are control signals. I will show in the next slide how it operates. RD is the read signal. We can observe that when you have to activate the read signal, you have to activate RD. Now it is as you can see, RD has bar over here. That means when you have to activate this read signal, you have to provide the logic 0 rather than logic 1. Okay, so यहाँ पर जहाँ पे there is no bar at the above, that means you have to provide the logic 1 for activation. Whereas if you wanted to activate such a signal which has a bar over their head, then you need to provide the logic 0. And WR is a write signal. Then we have an address bus and data bus. Here we can see the address bus and data bus has been multiplexed. We know that microprocessors, especially the 8085, has 16-bit address bus, 8-bit data bus, and it has a 40-pin package. Now, I start adding all the bits of the control signals, external acknowledgement, external initiated signals, interrupt signals, video communication, power signals, crystal signals. Then it will go above the 40-pin package. But we can only construct 40-pin package. To keep such a thing within the 40-pin package, we need to multiplex something. Here what they have done the address bus multiplexed with the data bus. Now, address bus, as we know, completely of the 16-bit. They have divided the 16-bit into the two parts of 8-bit. The lower part is called lower address bus. The higher part is called higher address bus. The higher address bus, lower address bus A0 to A7, total 8-bit. Higher address bus A8 to A15. Now what they have done, they have multiplexed this lower address bus with the data bus. Since it is a 8-bit, it requires 8-bit data bus. It's a multiplexed with the address bus, with the lower address bus, it will be named as AD0, A for address, B for data. AD0 to AD7, AD0 to AD7, lower address bus, and A8 to A15, higher address bus. As you can see, this part is A8 to A15, higher address bus, and AD0 to AD7, lower address bus. As since it is the address bus plus come inside the 8085 also. But since the address bus, higher address bus, will only provide the address to the peripheral. Therefore, it is a unidirectional. Apart from this, we have a power supply signal like 40 pin and 20 pin. 20 is grounded, 40 is 5 volt supply. Then we need to synchronize 8085 with some clock signals so to provide the clock to the 8085. Therefore, we had two pins X1 and X2. Within these two pins X1 and X2, we can provide two types of clock signals. One is the RC clock. RC clock मतलब resistance capacitor clock, or second is the Ford's crystal. 8085 also can provide a clock to the other peripheral to synchronize communication. For the synchronized communication with 8085, so the clock out, and even it can reset the peripheral with the reset out. As we already discussed some of the control signal over here, like address flag number S0, S1, I slash number. I will explain this operation of S0, S1, I slash number, read and write signal in the next table. You can see that when you are wanted to communicate with the memory through the 8085, that is memory block with the help of 8085, you have to keep it logic 0. This whole part is memory communication. You can see M0 is IO slash M bar is 0. Therefore, we are communicating with the memory only. And when we are communicating with the input-output devices, we have to keep it as the logic 1. Apart from this, we can see S0 and S1 condition when both are 1 plus RD bar is 0, then the op code will be fetched. Now, what is op code? Op means operational code. That is the program language, the program which we have written for the operation of the 8085. That will be fetched inside the 8085. And to read the memory, we have to keep S11 and S00 with the read signal 0. Or if we wanted to write into the memory, we have to write 01 with the write signal. These control signals is needed with these status signals to make the communication. Now, how they are working? So, through this diagram, you can see IO slash M bar is connected to all 4 of these with the read and write signals. If there is a IO slash M bar 0 and read signal is 0, memory will be operated. And if there is a write signal, then memory write will be operated. And if there is a IO slash M bar is 1, we can read the input output devices, or we can even write into the input output device. Now, as we have already discussed that the address bus and data bus has been multiplexed. Now, how this multiplexer address and data bus is used for the next operation? Now, we know that we have provided a clock through the crystal X1 and X2 pin. Quad crystal has been used to provide the clock to the 8085. We can use quad crystal. We can even use the resistance capacitor pair, RC pair, to provide the clock to the 8085 microprocessor. This clock has been converted into the machine cycle. And this machine cycle has a 3 main cycles: T1, T2, and T3. Sorry, T1, T2, and T3. Within these 3 machine cycles, we have to complete one instruction. Now you can see that at the first machine cycle T1, this whole bus A8 to A15 and AD0 to AD7 acts like the address bus default. But for the second and third, it acts like the data bus, especially the lower byte of the data bus. Okay, this is the default setting given in a 8085. But for some of the operations, what we need that address was to be appear in the machine cycle 2 and machine cycle 3. For that, they have provided us a address latch enabled pin. If we make it logic 1, then its latch will be activated and make this lower order address bus as address bus in the second and third machine cycle through the latch 74373. This way, we can use the whole 16-bit address bus plus 8-bit data bus, which is multiplied with the lower order address bus. This is the architecture of the 8085. It has been divided into different parts depending upon the section, operation or functionality. Like we have an interrupt control. I will go step by step from top to bottom. You can see. Now we have an interrupt signal. 5 interrupts are there. In 8085, INTR, RST 5.5, 6.5, 7.5 and track. We have a one interrupt acknowledgement signal INTA. You can see this. And we have a serial communication control through the SID and SOD. SID serial input data, SOD serial output data. These blocks are directly connected to the 8-bit internal bus. You can see this is the whole 8-bit internal bus. Okay. Then we have accumulator, uses of the 8-bit, temporary register, uses of the 8-bit. Accumulator is directly accessed to the programmer, therefore it is a bidirectional data which comes inside and also goes outside of this. This accumulator and temporary register is directly connected to the arithmetical logical unit. Now, temporary register is unidirectional as it is not available for the programmer to access. Only the processor can access this temporary register. Apart from this, we have a flag register which provides the status of the operation currently used. Then we have an instruction register where all your outputs come inside 8085 and kept into the instruction register for decoding purpose. Here is the instruction decoder which creates the machine cycle and involves the operation what it has to be done and provide the timing and control signal to the timing control unit. Now, as you can see, this timing control unit, you will observe that timing control unit has all the signals which is required like clock out, crystal X1 and X2, control signal like read, byte, status signal like S0, S1, IO flash and bar, ALE signal that is address latch number signal, DMA direct memory access signal like hold and hold acknowledgement. Apart from this, we have a control signal like reset in and reset out. Then we have special registers used for operations. Like there are 2 temporary registers given to the 8085 for its own use, that is W and Z. It is not accessible by the programmer. But apart from this, programmer can access B and C, D and E, H and L. These are the individual registers, but when we make the pair, they make the 16-bit register. And B is the 8-bit register. And when it is paired with the C register, it becomes 16-bit pair, that is BC pair. Similar way, there is a DE pair and HL pair. Then we have a stop pointer, program counter. Stop pointer is up to 16-bit and program counter is also for 16-bit. Then we have a address latch which make the address buses and data buses separated. Since data bus is directly connected to the internal data bus, 8-bit data bus, the lower address come data bus is directly connected to the internal 8-bit data buses. Apart from this, control signal is provided to every block of the 8085 architecture. Now, to understand as a programmer, what are the provided for the operations, we need to understand the programming model of 8085. As we know, it has an accumulator where all the operations are performed. In 8085, all the operations will perform into the accumulator. All arithmetical and logical operations performed in the accumulator. Its flag register shows the status of the current flag. It is also known as the PSW when worked with together. Program status word. Accumulator plus flag register combined is known as the program status word of 16-bit. Apart from this, we have B, C, D, E, H, L register pair of 8-bit. When they are paired, it will become 16-bit pair like BC, DE, and HL. Then we have a stub pointer of 16-bit, program counter of 16-bit. We have a 16-bit address bus, and which is unidirectional. That means 8085 can access to any peripheral, and peripherals are not allowed to access the 8085. Whereas data bus are bidirectional because data can flow inside the 8085 and it also can flow outside the 8085. Now, this flag register, which is the part of the program status word, is of the 8-bit, but we have only 5 flags. Okay, what are these flags? As you can see, this is the 8-bit register D0, D1, D2, D3, D4, D5, D6, D7. Now, D0 acts like a carry flag. Due to any operation, arithmetical logical operation, if there is a carry generated, then the carry will be stored into the carry flag. Similarly, D2, which acts like a parity flag. Now, due to any operation, if numbers of 1 into the accumulator is even, then parity flag will be having a logic 1, and if it is odd, it will be has the logic as a 0. Even parity hai, then it will have a logic 1, or if it has 0 for the odd parity. Similarly, as we know, all the operations into the 8085 is done on the 8-bit data. That means we have a 8 total bit to be added. Then 8-bit, that means 2 nibble. Now nibble is what? 4 bit. Nibble is what? 4 bit. So after any arithmetical addition or subtraction of 4 bits, there is generation of carry, that is known as auxiliary carry, which is stored into this auxiliary carry flag. Okay, एक निबल ऐड होने के बाद when there is generation of the carry, it is stored into the auxiliary flag. Then we have 0 flag. Now 0 flag is a flag due to any operation or any arithmetical and logical operation performed in an accumulator, and the result has been generated in such a way that the 8th bit of the accumulator is 0. To show that the accumulator has been 0 after the operation has been performed, the 0 flag becomes logic 1. Similarly, the MSB, that is the most significant bit of the accumulator, Due to any operation, if this most significant bit of the accumulator has a logic 1, then the sign flag is set, otherwise it is reset. Setting the sign flag shows that the number into the accumulator is a negative number, and when it is 0, the number into the accumulator is a positive number. With this, now we will stop, students, and for studying the next, we will go for the instruction of 8085 and see how operation is performed into the 8085 in the next lecture. Thank you.